Over the past few videos, we've been looking at somewhat disparate things. We've been looking at .NET Worker Services and then also how to write clients for SignalR, firstly in Blazor and then last time in WPF. And this week, and indeed in the next video, we're going to look at how all those things fit together, because it addresses a particular problem that we can have when we're dealing with SignalR, but also more broadly a problem of compatibility between different versions of .NET and indeed different systems outside of .NET as well. Now let's take a look at what I've done. What I've done here is made a slight change from last week in that we've now got not just a WPF client written in .NET Core, .NET 9, but I've also put one in .NET Framework. And also I've had to put in a new hub for that. So you can see here we've got the Framework hub and the Framework WPF client. I've made a few changes because they are different libraries that work with Framework and with Core, but I'm not going to go through this in detail because it's pretty much the same. You can look at the source code to see the difference there. But I've got those set as the startup projects, so if we just check in there, we can see that it's the Framework client, the Framework hub, and if we run that up, then we won't really notice very much difference. So you can see there we've got the JavaScript-based client, and I've just dragged in the WPF client, and it works in the same sort of way. If I enter Harry there and then go for Sally here, we can see we've got that working in the sort of way that we're used to. So nothing new there, but rewritten for Framework. And although that works fine, there is a slight problem because I had to rewrite both the client and the hub. I've still got my SignalR hub, and if I just switch that over, so if we go into the client and go to the game view model, and you can see here is where it's making the connection. So I'm just going to swap those so that that port 7234 is the port for the core hub. And then let's also change the startup projects so that we're not going to go for the Framework hub. We're going to go for the core hub. Start that up. But immediately you'll have noticed we got in there an error. It cannot connect. There is a complete mismatch between the protocols used in SignalR in .NET Core and what was used in Framework. And although the underlying protocols, which are WebSockets and HTTP and things like that, they're very stable, but SignalR is a layer on top of that, part of .NET, and they changed it, and we haven't really got direct compatibility between Core and Framework. Now, there's a number of ways around that. One thing you can do, if you're using a recent version of Framework, because those recent versions are compatible with .NET Standard, and Core is compatible with .NET Standard, you can actually switch up to the core version of SignalR on your client, which in many cases is going to be by far the easiest way to go. But the thing to bear in mind, that only really works from .NET Framework version 4.6.1 onwards. Now, although you might think, well, even 4.6.1 is out of support now, actually, going back to 3.5, that's in support till 2029. And actually, that is what I was having to use when I hit this particular problem, a quite old legacy system that needed to connect to a modern hub in SignalR written in .NET Core. So that's where that came from. But also more generally, the solution I'm going to show you isn't just about SignalR, it's about all sorts of compatibilities between different versions. So it's a general purpose solution. This is just the specific example. Another way we might fix it is like this. We could have our Framework hub and client, and we could have our Core hub and client, and then we could get the two hubs as web services to communicate between each other with HTTP. Now, HTTP you think might be a one-way protocol. It's certainly a one-way protocol between clients and servers, but between two servers, because they can both receive requests from the other, you can actually use it as a two-way protocol. So that would allow you communication from the WPF Framework client to the Framework hub, to the Core hub, and then out to the Core client and back again. So it is a solution, but it is rather complicated. It's introducing a whole new process for the Framework hub, though in fact we do introduce a new process in what I'm going to be showing you here anyway, but also it's duplication of code, also that new hub needs to be hosted, so it's not the greatest solution. The solution I'm going to show you here uses that idea of the worker service and uses that as the bridge between the world of .NET Framework and .NET Core. And that's the key general purpose thing that I wanted to show you, how you can use a worker process to do this with all sorts of different compatibilities. This SignalR thing is the particular example that I was trying to solve when I came up with the solution. So we're going to have to split this into two videos because it's quite a big area. What we're going to look at this week is just the basic structure of using the worker service. And then next week, I'll just fill in all the detail to get it fully working, and we'll get our rock, paper, scissors working again. So let's look at what we need to do here. And the first thing we need to do is put in our worker service. So what we're going to do is add a new project. We're going to make it another one of these worker services. We're going to call this SignalR worker. Just going to leave this as .NET 9, so the way we're going to communicate back to Framework doesn't matter what version you're using. Click Create on that. That will give us our SignalR worker. Not going to do anything with that for the moment, but the key thing we're going to do is rather than running that up as a application in its own right, we're going to launch that from the WPF client. So in the WPF client, I'm going to put in a new class, and I'm going to call this Worker Service Proxy. Okay, proxy, it's going to sit between the actual application code and the worker service. And then in here, I'm going to declare a private, and then this thing called process, which represents a subprocess. And then we'll just call that underscore worker process. And then I'm going to give this a public method called start. And in there, I'm going to say underscore worker process equals new process. And then I'm going to do a quick build because I need to have access to the executable for this SignalR worker that we just added. So if I just do a build of everything, which isn't going to do very much at that stage, but then I'm going to bring up File Explorer and just drill down into the SignalR worker bin debug .NET 9, and then I'm going to copy that path, and then back over here I'm going to say underscore worker process dot start info dot file name, make that verbatim because it's going to have backslashes in, put all of that in there, and then also on the end of that the actual name of the file, and so we should be able to see we've got that somewhere there as the SignalR worker.exe. So if we copy that as well, and so that is going to tell it where to find the process to start up. Obviously, in production, you'd be putting that somewhere different, but just for development, we can get all of that working. Then we're going to put in a couple of other things. So we're going to say underscore worker process dot start info dot use shell execute. Set that to false. That just means we load the executable directly. And then the other thing I'm going to do is we're going to have worker process dot start info dot create no window, and I'm also going to set that to false. What that means is when it launches, it will display a console window so that we can see all the logging and that sort of thing. When you're running this for real, you probably want that set to true because you don't want to clutter up the screen with extra windows, but it's really useful during development. And then having done all that, we can simply say underscore worker process dot start, and that will kick off our worker process as a subprocess of the WPF application. What we should also do, just for a bit of tidiness, we need to do some shutting down as well. And so what I'm going to do is make this worker service proxy disposable, and then implement the interface, and then in the dispose, I'm going to do an underscore worker process dot kill. That will give it a hard kill, so it won't wait for it to stop. We don't really care about that. You may in different circumstances. And then probably belt and braces, but I'm going to do a dispose on there as well because that is itself disposable. So that has a start and a dispose so that we can manage the worker process. Now let's put that into our game view model for now. So I'm just going to put in there, up here, our private, read-only, and then worker service proxy. And then in the constructor, let's create that. And then where we did the start for the hub connection, that's going to go eventually. But in here, we'll say underscore work service proxy dot start. Then we're going to make this also iDisposable. and again do an implementation of that. I'll do it directly to generate the code, so through the worker service proxy. So we should see there's the dispose working. And the slight problem in WPF doesn't actually automatically dispose of view models even if they're disposable. So we've got to do a bit more work there. We've got to go to the XAML and go to the properties and then events. And just like we had to have a loaded in the previous video, we're going to have a closed. And that, there you can see, is where we made our connection. Here we're going to put that in again, and that's where we're going to have to manually call the dispose. So that means that this subprocess should shut down as well. One last thing I'll do, actually, I will not make that hub connection anymore, because that's just, remember, going to crash it because it can't connect to the hub. Also, I'll change the startup. So in fact, let's for now just go for starting up the client. And so now when we run that up, then we can see here we've got the WPF, even though that's not going to work. But here we've got the service worker. And remember, the default one just churns out this logging every second. The other thing to notice, though, when we shut down the WPF, it also shut down the worker process because of what we did in the dispose. So that's pretty neat as to what's going on there. We've launched and we've shut down, but it's not much use being able to launch that unless we can actually somehow communicate between the framework WPF application and the .NET 9 worker service. We need a technology that hasn't changed, that's common between both of those. So what we're going to use is a very nice Windows technology called anonymous pipes, and that's worked the same for years, so it won't cause us any issues. So what we're going to do is this. We're going to introduce into our worker service proxy, I'm going to put in a couple of these. So I'm going to have a private and then anonymous pipe server stream, and I'm going to call this one pipe out. Because the thing about these is they are one way, so we can only send information in one direction on them. So if you want bidirectional communication, you've got to have two of them, and we call them pipe out and pipe in. So we've got a couple of those, and we can use those to send messages out, receive messages back. You can't actually use them directly. You need to wrap them in either a StreamReader or a StreamWriter, depending on which way we're going. So we're then also going to have a private StreamReader, which we'll call StreamIn, and a private StreamWriter, which you've guessed it, and so the editor we'll call StreamOut. So that's what we're going to have in there. And then when we do all of this setup, we've got to do a little bit more there. So as well as creating the process, we're going to have to create our two pipes. So we're going to say underscore pipe out equals, we've got new there. And then a couple of things we've got to put in. We've got to put in a pipe direction of out. So you'll notice it's the same class, whichever way we use it, so we configure it like that. And also we put this inheritability on there so that it can be picked up by the child process, which is the whole point of what we're doing there. You may also notice we have an in-out option there, which would be really convenient, but actually it doesn't work with anonymous pipes. We're also going to do a similar thing for pipe in. And as you might guess, in this case, we've got the direction as in, and we have the heritability as the same. So that's our pipes. So the next thing we need to do is somehow inform the worker process about these pipes so it can connect to them at the other end. And we do that simply by using a handle, which is a string. So what I'm going to do here is on the worker process, again on start info, but this time I'm going to use the arguments. So these are just simple command line arguments like you have with any application that you'd use if you're typing at the command prompt, but we can use them here as well. And so what I'm going to say, I'm going to use string interpolation. And so the first one of these is going to be underscore pipe out dot get client handle as string. So that gives us the string representation of the out pipe. Then remember, command line arguments are just space separated. So put in a space, and then we're going to do pipe in, and then exactly the same thing, and that should all be okay. So that will pass those arguments in there when we run it up. A few more things we need to do at this stage. Once we've done that, we can then get rid of that handle so we can't reuse it. So we have the pipe out dot dispose local copy file handle just to tidy up after ourselves, and similarly for pipe in. And then lastly, we just need to set up those readers and writers. So we're going to say stream in equals new stream reader, and then we pass in pipe in. So that's going to be receiving messages from the worker process. Stream out is going to be a new stream writer, pipe out. And then the thing that I very often forget when I'm doing this sort of thing, on here we want to put auto flush equals true. So that means that as soon as we write to stream out, it will send it through to the pipe and through to the worker process. And if you forget to do that, it looks like it's all working, but those messages just accumulate and don't get pushed out typically until you shut down. Very confusing. So remember to do that when you're doing the writer. Don't need it with the reader, doesn't make sense then. We need to do a little bit more tidying up in our dispose. So we really just in here then also need to dispose of our stream in and of our stream out and of our pipe out and of our pipe in. So all of those things, strictly speaking, need disposing, even though we're shutting down, so it'll probably tidy up anyway, but put those in for safety. Okay, so now we've established those channels of communication at this end. Let's now do those at the other end. So let's go to our SignalR worker, and in here we can pick those up in the program. So we're using top level statements here, but the args, the command line arguments, are actually hidden in there just as it would be if we had a full-blown program and a main. So what I'm going to do is simply enough, I'm just going to in here say var inpipe equals args, see the args is there, 0, and then var outpipe equals args 1. So notice, got to get the order right, and I've switched those deliberately. So in the proxy, if we look at the parameters, it was here, outpipe first, then inpipe. But remember, the outpipe for one of these processes is going to be the inpipe for the other one, because they're communicating with each other like that. What I'm then going to do is go to our worker. Remember, this is the one that's just created out of the box looping like that. I'm going to get rid of the logger. Should have logging really, but it's not the important purpose of what we've got here. And let's just leave the loop in there for now with the delay. And then what I'm going to do is on here, add in a constructor. So we'll put in a constructor, and that's going to take those two parameters. So we're going to have string in pipe and string out pipe. And then back in here on that add hosted service worker, we'll then explicitly create that. So we'll put in an arrow function with a discard, gives us back a new worker, and then we can just pass in that in pipe and out pipe directly. So that will set that all up for us. And in fact, we don't need that there because it can work out that it's a worker. Okay, now we've got to make some use of that. So now at this end, remember on our WPF application, we had this idea of the anonymous pipe server stream. Well, given that counts as the server, we're going to be the client. So what we're now going to put in here is a few private fields. We're going to have a private, read only, and then this is going to be anonymous pipe client stream underscore pipe out. Another one for pipe in. And then again, we're also going to have a reader and a writer. So just the same as we've got over here. In fact, I'm just going to steal them. So those are going to be very similar. And then we're going to have to create those in the constructor. So we're going to say pipe out equals new, and then client stream. This one is going to be a pipe direction of out, and is going to take the handle of the out pipe. So that's how ultimately it connects up to what we've done on the server, the WPF application. So that's what we've got there. And then similarly for pipe in, change to in, and in. And so that's hooked us up to our two pipes. Then we've got to set up our streams. So underscore stream out equals, and then that's going to be a new StreamWriter connected up to pipe out. And once again, let's remember to do the auto flush because that's writing. Stream in, StreamReader for our pipe in, all perfectly okay. So that's that lot all set up. Again, that needs to be disposable, but actually background service already is disposable. So in this case, we've got to do an override of dispose, calling the base class dispose. And then in there, we're just going to do our pipe out dispose, our pipe in dispose, our stream out dispose, and our stream in dispose, just to keep that all tidy. Okay, then let's now in here start making some use of that. And what I'm going to do is in the loop we've got here, I'm going to basically in there sit and wait for some message to come in. So what I'm going to do is say var message equals and then underscore stream in dot read line. So that is going to block until the WPF application sends us a message, which will simply be a string. What we'll do later on, we'll use JSON, but I'll just use a plain string here for now. And so that's what we're going to see. What I'm then going to do, just to get this working, not really directly related to the SignalR at all, I'm going to, after a delay of 1 second, I'm going to say underscore stream out dot write line, and then I'm going to say you just sent me the message, and then we'll put message in there. So it just sends it back, just so we can see that the two-way communication is working. And really that should be all we need on the worker service. So let's go back to the client now, and what I'm going to do is go back to my game view model and hijack a little bit. So let's go for that register function. That's not going to work because we've got rid of that. So what I'm going to do is on here just say underscore worker service proxy, and then we're going to say dot send message, and then let's just use the player name as the message that we're going to send. Let's generate a stub for that and go in there, and then what we have to do in here is simply say underscore stream out dot write line. That should really be a message because it doesn't have to be the player name, and we'll send the message in there. I remember that stream out we made as auto flush, so that will just send it straight through. Now, before we actually look at the message coming back, let's actually test that to see if the message is getting there. And testing and debugging can be quite tricky with one of these worker services, and there's a couple of things you have to watch out for. One is, remember the SignalR worker is running entirely on its own, and there's no dependency within Visual Studio on SignalR worker, which means if we run this up, then although that will automatically build the thing we're running, which is the framework WPF client, it doesn't automatically build the worker because there is no dependency between those two projects. So you have to remember, it's a bit irritating, to build the worker every time you change it, because running the client, although it will build the client, won't build what we have there. So that's done the rebuild on there. Now how do we debug it? Well, what we need to do is we need to go to the program for the SignalR worker. And what I normally do at the very first line, I just put in there debugger.launch. Okay, and that's a general thing you can do in any application that will, even though you haven't run it from Visual Studio, offer you the opportunity to run it from Visual Studio. So what I tend to do, I put that in there, and then if I'm not that interested, comment it out or leave it in. Get rid of it completely when you're releasing the application, but just put that in there for now. Another thing we need to do though, let's just give that another rebuild before we forget, is we need a separate instance of Visual Studio to get that to work, but it needs to be one that's loaded the correct project so that we can actually do the debugging. So I'm going to run up a second instance of Visual Studio in exactly the same solution. So if we just drag that over there, then that's basically the same thing, and I'll just minimize that for now. But now let's run this up. So if I click start, that, remember, is going to build and run the client, and then we can see what happens is the worker process, which we've got in this window here, has hit that debugger.launch, and it's offering us either a new instance of Visual Studio or that second instance that I just launched. It doesn't give us the main one because that's already running in the debugger. New instance I find isn't much use because although it will open up the debugger, it doesn't know where the source code is, so that's why I opened this one already. So open that one up, and then you'll see that we've broken there in the debugger.launch. And so what we can now do is put a break somewhere else. So let's go to the worker, and we can put a break there just after the message has been received. And then we'll go that again, and that should all be okay. Here we've got our welcome, and remember what it was going to do is take that player name, and then when I click enter, it should send it off. So I'll click on enter, and you can see we've broken there, and we've got this message as Harry. So we can see that part of it is working, and also we can see more generally very, very useful how we can do debugging of a process that's been launched other than in Visual Studio. So I'll continue that, but it's not going to do anything because we haven't been listening to what's going on in there. So what I'm now going to do, close that all down, remove that break, and now let's start listening at the other end. So we'll go back to the original Visual Studio. It doesn't really matter too much which, but it's easier to just use one of them for editing, one of them for debugging. And then we will go to the worker service proxy, and we're going to have to start receiving. Now, the thing about receiving, just like we saw it actually in the worker, is unfortunately you can't do something like have an asynchronous await on that or have a callback. It just blocks until the message comes in. So that would wait at line 26 until a new message comes in, then processes it, go around the loop again, and that's what we have. So we've got to have something similar to that. Now here we've already got a loop doing that, but we're going to, in the worker service proxy, we're actually going to have to kick off a separate task in order to sit and wait for this blocking call without hanging up everything else. So that's what we're going to do here. So what we'll do is in here, at the very end of all that, I'm going to do simply a task.run, and then that's just going to take a lambda, no parameters in here, but that's what we're going to have for all of that. And then in here, what we need to do is, well, firstly put in a try block, basically so that if anything goes wrong, this will just terminate in a nice friendly way. So I'm just going to put a catch and then nothing at all in there. Probably you'd want to do that a bit more seriously, but for now that'll do fine. And then we're going to have what will be an infinite loop until we get the exception, which will basically be what happens when this all terminates. So we're going to put that in there, and then here is where we can do our var message equals, and in this case we do our streamin.readline. So really exactly the same as we had within the worker service, but this is for the messages coming back. So we've got that, and then all I'm going to do on that is I'm going to, just to get this working with what we've got here, I'm going to do something very simple. I'm just going to do a message box.show, and then simple as that, just going to pop up that message. You might be a bit worried about doing a cross-threaded call here because we're in this separate task, but actually for message boxes, WPF handles that fine. So let's run that up. And firstly, in this case, I don't want to debug because I'm hoping it's going to work. So just click cancel there, and then that will just leave the process running. There we can see that worker process, but now we're mostly interested in the WPF. And so what I'm going to do there, send a message, hello, click enter, and then back comes the response. Remember, there's a 1 second delay we put in there deliberately, and you just sent the message hello. So we can see that's all working fine. Click OK on that. We can do a goodbye. Enter that, again the 1 second delay, and then we get the message goodbye. So that's really as far as I want to take it in this video, because the next video we're going to be hooking up the actual SignalR functionality there. But already we can see a way, really fairly simply, that we can communicate between what we have in a framework WPF application and what we have in a .NET 9 worker service, and how we can communicate between them using those anonymous pipes. So that part of it, very, very general purpose. Next time we'll look at the specifics for SignalR, but I hope you enjoyed that. If you did, click like, do subscribe, and I'll see you next time.